In the last assignment, we used the behavior tree to improve the control of the enemy, and also can find out the position of the enemy and notify the other enemy. In this assignment, based on the original games, our group planned to make a maze which can generate different rooms and generate the enemies in each room. Before start, we want to talk about the algorithm of our maze. We select the recursive division method as the basic because it's quite simple and the effect is really good. As for the recursive division method, we need to set up position in a range of the map, and then division this floor by two walls. The one is the horizontal and another one is the vertical. We need to generate 4 walls and pick the random position to open a door on the 3 of them. And then we can get 4 rooms with doors and 1 way to get through. After that, we need to repeat to splitting the different rooms until we get a whole maze. Now let's get started. Firstly, we have to create an actor of the maze builder. And then we need to define the variables of the width and length of the map, and the height, width, and width of the wall, and the width of the door. We need to make them can be added anywhere. After that, we need to define 2 functions, which are generate maze and generate floor. And we also need a procedural mesh component to contain the mesh of the floor. We also need to assign the value to the map width and map length in the constructor. The process of how to do the generated floor is quite similar to the content in the lab, so we don't explain that much. The last step is to establish a floor according to the map width and map length in the procedural mesh component. Okay, let's test it. Now, we have to define the wall mesh first in the procedural mesh component. It is very similar to the generated floor, but we have to use the procedural mesh component because the maze contains of many different walls. So we need to create a template function to reduce the codes. In the generated walls, there are 4 arguments separately defined the cube, including the close side and the far sides of the x and y coordinates. We also need 2 arrays. The one is to store all the vertices, and another one is to store all the triangles. We have to set up all the 8 vertices of the cube in the array. After that, we also need to set up all the triangles in the array. In order to make the code more clearly, I have made functions to add triangles. Now we create an integer called total vertice. In this function, adding up total vertices and the temporary position of triangles to map up the various faces of the cube. The builder generated the maze. We have to create 4 walls which are the boundaries of the map according to the map width and map length. At this time, we also need to assign the value to wall height and wall width. Now let's have a look at it. As you can see, the 4 wall has been established as a boundary of the maze. And next, we need to split the room for the maze. In this function, there are 2 arguments to define the position of the room, which are the bottom left and the top right. Firstly, we need to generate random layer positions in the side of the room. To generate the random float easily, we create a function, random float, to generate a random number between 2 floats. We make the position of random x based on the top right axis and the bottom left axis. We also need to create a random y-axis. Based on the random position we generated, 4 walls has been generated here, which can split room into 4 parts. Okay, let's test it. As you can see, the maze has been split into 4 parts. The process is random, so there's many ways to split it. Now we need some dots on the wall. Let us back to the code. Firstly, we need to generate a random number from 1 to 4. Each number means one wall. If the wall has been selected, then we generate a whole wall. Otherwise, the rest of the wall will be generated with the door. After that, we need to generate a random position as the position of the door. Now, let's repeat the process. We need to write down the same code into the different wall. Okay, let's do some tests. As you can see, each wall contains a door right now. And the process is generated randomly, so we try again. We almost done the basic job. Right now we need to use the recursive method to repeat the process and generate more rooms. As we need to use the recursive method to generate more rooms. And now we use the maze split to split different rooms. This process is quite repeatable from the previous codes. And now we set up a condition that when the size of the room is small enough, we create the recursion. Okay, now I let the room limits as the 10 times of the width of the door. Okay, now we do some tests. As you can see, the maze can be successfully generated with lots of different split rooms. Each time we play, we can generate a different type of the maze. My groupmate define a room and generate the enemy in each room based on my work. As you can see, in the maze, there are lots of different split room has been randomly generated, and in each room there's an enemy has been generated. At the same time, my groupmate has already generated an end print as the condition of the end of the game. There are also some drawbacks. For example, because we don't have enough objects in each split room, so if we generate a really large maze, then we can easily miss the way and miss our location. Based on that drawbacks, we really hope that there is a breadcrumb system that can show the path and player has passed through. We open the player blueprint. When the event starts, we added a new timer event. We named it Add Track. We need to add up new spline component in the player character. When the trigger has been called, the point has been added in the spline. We need to create a new integer called next point and connect with the add point component. We need to get the position of the actors and the forward vectors and then put them into the add print component. Then we need to add a new spline mesh for the visualization. When the value of the next point is greater than 1, then we need to create the start position and the out position of the new spline mesh. Now we need to get the current data and the previous data of the spline as the value to set up the spline mesh. In order to generate a better line, we have to add local offset to the spline mesh. Now you can see there is a clear path. And this blueprint will easily make us understand where we come from and which room has been visited. And this will easily to solve the problem we mentioned before. Now, we can't easily get lost in the maze. My teammate also improved a lot in this work. If there's an empty room, the enemy in that room will patrol until they see a player. When the enemy see a player, then he will follow the player until the health point is too low. Then the enemy will be destroyed because there's no health point. When a player enters an empty room, if there's no enemy, then the game will generate a new enemy in that room. This improvement has already enhanced the interactions with the players, which can largely enhance experience in the game. In this assignment, I spent lots of time dealing with the algorithm, and which made me learn a lot technique related to the procedure content generation. As for the assignment 4, we want to add more functions and more interactions with the players, and we also will add more behaviors of the enemies that will enhance the game experience. And for the map, we can add more objects, and for example, we can add some weapon that the player can pick up, and we also can add some interaction activities with the enemies, and we also have the winner lose conditions, also add some health point of the. Thank you for your watching and looking forward to your feedback.